Alright, these are the notes for Algebra 2, Section 4.5 in your textbook. This is Part 2 of Section 4.5. Section 4.5 will be split into 3 sections. The first section dealt with simplifying radicals. The second section is going to deal with using conjugates to rationalize denominators. Now, before we get started, a little bit of vocabulary here. Rationalizing the denominator is still, even though we've already seen this, is still the process of eliminating a radical from the bottom of a fraction. So if we want to get rid of a radical from the bottom of a fraction, we have to rationalize the denominator. Conjugates are used to rationalize a denominator. Their products are always rational numbers, and that is always. Every time you multiply two conjugates together, you always get a rational number. Now the table here shows you conjugates. Alright, these are numbers you multiply together to rationalize a denominator. Now the first one we've actually already seen. Right? If we have square root of b on the bottom of a fraction, we multiply it by itself. Just as a quick example, we know that if I had 1 over the square root of 5, I would, in order to rationalize this denominator, to get the radical from underneath the denominator, I multiply it by itself. That's where this comes in. The form of the denominator is the square root of b, the square root of 5, and I multiply both the numerator and the denominator by the square root of b, the square root of 5. And when I do that, I have 5 over the square root of 5. And that would be the simplified version because the denominator has been rationalized. And that's the one we've seen before. Now the ones we haven't seen before are if we have something in the form of a plus the square root of b or a minus the square root of b. That might be something like 3 plus the square root of 5 or 3 minus the square root of 5. If we have something like that on the bottom of our fraction, then we still need to rationalize the denominator. But in order to do that, we have to multiply it by its conjugate. And the conjugate is basically, it's the same numbers, but the operation has switched. So if I'm adding a plus the square root of b, the conjugate is a minus the square root of b. And if I have a minus the square root of b, the conjugate would be a plus the square root of b. Now let's see how this works in practice. I want to simplify this fraction. 4 over 5 plus the square root of 3. Now, let's see here. First of all, I want to know what the conjugate of this denominator is, because I'm going to have to multiply by that conjugate. Since this is 5 plus the square root of 3, the conjugate is 5 minus the square root of 3. That's my conjugate. So that's what I'm going to multiply the top and bottom of this fraction by. So that's what I'm going to do. I multiply the top by 5 minus the square root of 3, and I multiply the bottom by 5 minus the square root of 3. Now on the top I have 4 times 5 minus the square root of 3. And I can distribute. Right, I can distribute the 4, and I get 20 minus 4 times the square root of 3. Now on the bottom, when I multiply 5 plus the square root of 3 times 5 minus the square root of 3, something kind of interesting happens. What will end up happening is we'd have a sort of box set up. Remember, we used the boxes to multiply binomials, and it would work the same way here. Now we would have 5 minus the square root of 3 times 5 plus the square root of 3. We would have 25 minus 5 square roots of 3. Remember, if I have a regular number and a square root, when I multiply them, they don't combine. And then I have negative square root of 3 times positive square root of 3 would actually multiply together and give you negative square root of 3. Now, something interesting happens here. You might see that this term and this term, the two that we would combine when we were multiplying binomials, are going to cancel each other out. And that will happen every time. So all that's left is 25 minus 3. And that's what would go on the bottom of this fraction. 25 minus 3 is 22. Now there is a simpler way to do this, and we'll see that in a minute. For now, though, we're not quite done. We have this fraction 20 minus 4 over the square root of 4 times the square root of 3 over 22, which we need to simplify down to get our final answer. And when we do that, we can divide out a 2 from all of these. Right? We can divide this by 2 and get 10. We can divide 4 by 2 and get 2. We can divide 22 by 2 and get 11. So the fully simplified version of this is 10 minus 2 times the square root of 3 over 11. And that is our solution. Now you've noticed that I didn't combine the square roots with anything. Right? Even when we add, we can't combine the square roots with whole numbers. In fact, when we add, we can't combine the square roots with anything. Right? We treat them like they were x's or y's. We can't combine them unless they're exactly the same. And even if they're exactly the same, it would just change the coefficient. All right, let's look at this again. We're going to have several practice problems we're going to do. I'm going to see if there are some places where we can cut some corners and get some shortcuts going. Let's start just by setting it up. Now I have 3 over 4 minus the square root of 5. The conjugate of 4 minus the square root of 5 is 4 plus the square root of 5. So I'm going to start this out by multiplying 3 times 4 plus the square root of 5 times 4 minus the square root of 5 times 4 plus the square root of 5. Now this is where we can save ourselves a little bit of time. We can start by doing our distribution. We get 12, 3 times 4 is 12, plus 3 times the square root of 5 is just 3 times the square root of 5. Now on the bottom, here's what we can do. I will take my first number and I will square it. So I will square it and I will get 16. Then I will take the number under the radical and remove the radical. And then I will subtract them. Simple as that. That is equivalent to doing the box method that we did over here. And you'll notice it's the same thing. The first number is 5. We squared 5 and got 25. Then we subtracted the number under the radical, which was 3. 25 minus 3 is 22. Here, the first number is 4. 4 squared is 16. Minus the number under the radical is 5. So 16 minus 5. So our final product here is 12 plus 3 times the square root of 5 over 11. And we can't simplify that anymore because there's nothing we can reduce the fraction by. So we can simplify this process quite a bit. There was a lot of writing in this setup here, and in this setup there was a lot less. And the more practice we get at this, the quicker it'll become. Now, the last two problems are checkpoint problems, but I want to do them together. Let's start with negative 6 over 7 minus the square root of 5. Now, my conjugate here is 7 plus the square root of 5, so that's what I'm going to multiply by. So that's, let's see, we have negative 6 times the conjugate, and the conjugate is 7 plus the square root of 5. So we have negative 6 times 7 plus the square root of 5 on the top. On the bottom, we multiply the original expression by its conjugate, and we get 7 minus the square root of 5 times 7 plus the square root of 5. And when we do that, of course, the next thing we would need to do is distribute. So we distribute negative 6 times 7 is negative 42. Negative 6 times the square root of 5 is negative 6 times the square root of 5. Now on the bottom, my first term is 7, so I have 7 squared is 49. The number under the radical is 5, so I have 49 minus 5. Alright, so far so good. We're almost done here. I've got negative 42 minus 6 square root of 5 over 44. Now, as you can see, all of these share 2. Right, I can divide all of these by 2. I'll get 21 here, negative 21. I'll get negative 3 here, and 22 there. So my final answer would be negative 21 minus 3 times the square root of 5 over 22. And I'm done with that one. Now you notice every single one of my answers should have a regular, plain, single number on the bottom. They are pretty much all also going to have a square root on the top and an expression on the top. This last one, not going to be any exception. We have 4 over 8 minus the square root of 3. And we want to multiply by the conjugate. The conjugate of 8 minus the square root of 3 is 8 plus the square root of 3. So I multiply 4 by 8 plus the square root of 3. And I multiply the bottom, 8 minus the square root of 3, by 8 plus the square root of 3. Now, of course, I do this, so I distribute. And I get 32 plus 4 times the square root of 3. On the bottom here, I have the first number is 8, so it square that, I get 64. The number under the radical is 3, so 64 minus 3. Alright, getting close to the end now. We rewrite this. I have 32 plus 4 times the square root of 3 over 61. Now 61, let's see, what factors does 61 have? What do you think? Well, if you were me, you would think, oh, well, it doesn't look like it has much of any. And you would be right. This can't be simplified any further. So this is our final answer, 32 plus 4 times the square root of 3 over 61.